Okay. 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 See here and here at the first topic we are going to start about units and dimensions. Units and dimensions. Units and dimensions. And we know that and and we know that actually every physical quantity is being given some unit to indicate that physical quantity in terms of units. So here, if you want to find mass or if you want to find weight, you will give the mass in terms of kgs. So kg is the unit of mass. Without the help of units, and you cannot indicate any physical quantity like mass or time or length or anything. So you can indicate mass with the help of kilogram. So here, kilogram is the unit of mass. So in the same way, you can indicate any physical quantity with the help of the units only. So only with the help of units, you can indicate any other physical quantity. So here we have in basically seven. We have basically seven fundamental physical quantities. Seven fundamental physical quantities are there. Fundamental physical quantities means every other physical quantity can be indicated in terms of the seven fundamental physical quantities. So what are those seven? Okay, then now we shall see about those seven fundamental physical quantities. Those seven fundamental physical quantities are length. Here the first fundamental physical quantity is length, second is mass, third is time, fourth is electric current, fifth is it is the temperature, it is temperature, sixth is quantity of substance, quantity of substance, seventh is the luminous intensity, it is the luminous intensity. It is the luminous intensity. So these are the seven basic physical quantities what we have today. So in terms of these seven basic physical quantities, we can indicate almost all the physical quantities which exist in the nature. So these are the seven fundamental physical quantities which exist: the length, mass, time, electric current, and temperature, and quantity of substance and luminous intensity. In terms of the seven of fundamental physical quantities, we can indicate almost all the types of physical quantities. Then, so here and we shall see some examples in which way or in which manner we can indicate the remaining physical quantities in terms of these seven fundamental physical quantities. For example, we have speed. Speed can be written as, and we know that speed is equal to the distance by time. The distance, we know that it is a length, so it is a length by time, and we know that the length or time are the two of the seven fundamental physical quantities. So you can indicate in this manner any other physical quantity in terms of this seven fundamental physical quantities. So here if you want to indicate that so if you want to indicate the velocity, here the velocity equal to displacement by time. Here the velocity equal to displacement by time, and we also know that the displacement is also a length, so it is length by time. So here if you see here or if you observe here, speed and the velocity both have the same units of length by time. That means those quantities which have the same physical quantities, which have the same units, those quantities which have the same units need not be same physical quantities or need not have same properties. So here we know that speed and velocity are two different physical quantities. Speed is scalar while the velocity is a vector. So here these are two physical quantities which have same units but not exactly the same physical quantity. So here two or more physical quantities can have same units. So they need not be same physical quantities. And also here, we can write speed equal to speed equal to the distance by time, distance by time, speed equal to the distance by time. The distance is a length and the t is time. So this is L by t is that is called, it is the dimensional formula of speed. It is the dimensional formula of speed, or you can write this as LT inverse or L by T, which is the dimensional formula for speed. So in general, we can indicate, or we used to and try to indicate all the physical quantities in terms of the three most basic fundamental physical quantities: length, mass, and time. Of course, we have a total of 7 fundamental physical quantities. In them, we maximum used to try to indicate any physical quantities in terms of length, mass, and time. Here, the length is indicated. Here, we have seen that length is indicated by L and the time is indicated by T. And also here, what we used to know or what we used to understand is, so here we can indicate any physical quantities in terms of or in multiples like this, in multiples like this. So here these multiples can be, for example, we know that 1 kilometer contains 1 kilometer has 1000 meters. 1000 meters. Here we should indicate all the quantities in terms of SI units. So these SI units of these 7 fundamental physical quantities are length. If you suppose take length, the length has the SI unit, that's a system of international. That means the system of international. The system of international unit for length is meter, which is indicated by small m. Next we have mass. Mass has SI unit kilogram, which is simply indicated as kg, and the time has unit SI unit of second, which is indicated by small s. Next we have the temperature. Temperature is indicated in terms of Kelvin. It's the same as Kelvin. It is not like the degree Kelvin, it is simply Kelvin. So next you have quantity of substance. Quantity of substance is indicated in terms of moles, and which is simply indicated as MOL. MOL. Next we have electric current. Electric current is indicated in terms of amperes. Its unit is amperes, which is indicated by the capital A. Next we have at last the luminous intensity. It is the luminous intensity. The luminous intensity is indicated by, or it has a unit of candela in SI. Candela, capital CG. So these are the units what we have. So we used to indicate all these 7 fundamental physical quantities in the units of these 7. So here the length is indicated by meter, the mass is indicated by kilogram, here the time is indicated by second, and the temperature is indicated by Kelvin, and the quantity of substance is indicated by mole, and the electric current is amperes, and at the last we have the luminous intensity, which is candela. So here we know about meter, kilogram, second, Kelvin. Here this temperature is indicated in terms of Kelvin. Kelvin, this unit has come into existence as we try to indicate, or the basis to indicate if a physical quantity is any physical quantity should not be indicated in terms of the negative values. So here if you use the unit of the degree centigrade, the degree centigrade means we have both the negative values, zero values, and positive values, and all this. So any physical quantity should not be indicated in terms of the negative values. So in place of the degree centigrade, we have introduced a new system of units to the temperature called Kelvin. So here this Kelvin starts from, or it will start from the absolute zero temperature. So that is 0 Kelvin, absolute 0, it is absolute 0 temperature. 0 Kelvin equal to minus 273.15 degrees centigrade. So this minus 273.15 degrees centigrade is the least possible temperature. So this least possible temperature is taken as 0 degree Kelvin. So here as we taken the least possible value only, so there can't be any value less than that minus 273.15 degrees centigrade. So here there is no question of getting the negative values which indicate the temperature in terms of Kelvin. So here we have started using the Kelvin from then onwards, because any physical quantity should not be indicated in terms of the negative values. So for that, in place of degree centigrade, we have introduced a new unit called Kelvin. So this Kelvin starts from absolute zero temperature. Absolute zero temperature is the minimum possible temperature. So it is 0 Kelvin equal to minus 273.15 degrees centigrade. So from that, as we know that here we know that the triple point of water is 0 degrees centigrade. 0 degrees centigrade means 273 Kelvin. It is 273 Kelvin. And also here we know that the boiling point of water, here the boiling point of water is 100 degrees centigrade, which is 373 Kelvin. So from this, and we can understand that we have to add 273 to get the degree centigrade in terms of Kelvin. So next up, it is the quantity of substance. Next it is the quantity of substance. Quantity of substance, it has unit of mole. Mole means it is the number of atoms or molecules present in any substance or in any medium. As there are number of atoms in 12 grams of carbon C12, which it is. So it is the number of atoms as there are present in the 12 grams of carbon. So it contains nearly 6.023 into 10 to the power 23 molecules or atoms per mole. So in 1 mole of substance, there will be 6.023 into 10 to the power of 23 molecules in a mole. So in a mole, we can also say that 6.023 into 10 to the power of 23 atoms per mole if it contains a single atom. So if it is suppose if it is a monoatomic, we can write 6.023 into 10 to the power of 23 atoms per mole if it is monoatomic. We can write it as 6.023 into 10 to the power of 23 atoms per mole. Next we have electric current. Electric current is indicated in terms of amperes. These amperes can be written as, see here, if you have taken two wires which are parallel to each other, if the distance in between the two wires is 1 meter, and if it causes the force, here the amount of current is indicated in terms of amperes. It is indicated by capital A. Next we have the luminous intensity. The luminous intensity is candela. As we know that intensity is the power of the light incident on the given area. So it is candela. So here we have the luminous intensity. The luminous means light, intensity of light falling on a surface which is incident on a surface. So here it is luminous intensity. So again, if we come back to amperes is, if we place two wires which are parallel to each other at a distance of 1 meter in between them, then if it causes a force of 2 into 10 to the power of minus 7 newtons in between the two wires, then the amount of current flowing through those two wires is said to be 1 ampere. So here 1 ampere is the amount of current flowing in between or flowing through two wires which are parallel to each other, which are separated by a distance of 1 meter. If the wire causes force of 2 into 10 to the power of minus 7 Newton, if it causes a force of 2 into 10 to the power of minus 7 newtons in between the two wires, so the amount of the electric current flowing through those wires is said to be 1 ampere. Sir, because and the problems have not started. If I start once the problem, then I will be start. Problems are not started. This is only the concept. Sir, is my voice is any clear or any problem with my voice? Okay, it's little loud. Okay. Any problem with this? Okay. Maybe, and I have to put somewhat above. Okay. Okay. So, as we have written the SI units of almost the 7 fundamental physical quantities. For example, take length. Length SI unit is meter, we know that. But sometimes every physical quantity cannot be indicated in terms of only in terms of meters means it is a somewhat and tough to indicate each and every physical quantity of length, each and every length in terms of meters. Why? Because if you want to find the distance in between Earth and the Sun, it is almost 15 crores of kilometers. If it is 15 crores of kilometers, you can assume that means 15 crores of kilometers is the average. It is the average distance in between Earth and Sun. So 15 crores of kilometers means 1.5 into 10 to the power of 8 kilometers is the average distance in between the Earth and Sun. So if you want to indicate this point in terms of meters, it is 1.5 into 10 to the power of 11 meters. So there are many units or there are many lengths which are almost impossible to indicate in terms of meters. So we can use some prefixes to indicate almost all the physical quantities. Those prefixes we will write them in detail now. For example, so and I will start from the lowest. If you start from the lowest, we have 10 power minus 1, which is deci, and 10 power minus 2 it is centi, 10 power minus 3 it is milli, 10 power minus 6 it is micro, 10 power minus 9 it is nano, 10 power minus 12 it is pico, 10 power minus 15 it is femto is the prefix you have to add in front of the physical quantity. Suppose if you want to write a physical quantity like 10 power minus 6 meter, you will write it as, and we know that this 10 power minus 6 micro, it is micro. So here we have each and every symbol for each and every quantity. C, centi, milli, micro, nano, pico, and femto. So here if you want to indicate a length of 10 to the power of minus 6 meters, so you will write like this, 1 micrometer centi. So if you want to indicate a physical quantity like 3 into 10 to the power of minus 9 meters, so you can indicate this physical quantity like 3 nanometers. So here these units these are called prefixes. These prefixes should be added in between or in front of those units to indicate those physical quantities in a simple manner. So these are the decreasing values. To find or to have the increasing things which are more than 1, 10 power plus 1 it is deca, 10 power plus 3 it is kilo, 10 power plus 6 it is mega, 10 power plus 9 it is giga, 10 power plus 12 it is tera, 10 power plus 15 it is theta. So these are the physical quantities which we can see here like this also. These are the prefixes which should be added if there are values like 10 power plus 12 or 10 power plus 15, or with this prefixes we have almost have two other prefixes. For example, angstrom. Angstrom, 1 angstrom equal to 10 power minus 10. 1 angstrom equal to 10 to the power of minus 10. So we have these type of the prefixes also, which are apart present from these basic prefixes. So these prefixes have to be added in front of the units if those quantities or units are larger like these or smaller like this. So here after the indication of these the dimensions with the help of the prefixes, next we have some other issues or we have some other topics like what is the use of dimension? What is the use of dimension and why we have to write the dimensional formula? The dimensional formulas are written for the use. Why we have to use the dimensional formula? For example, these dimensional formulas, we can write the dimensional equations and we can find the dimensional equation. If the dimensional equation is correct, then only the equation is correct. If the dimensional equation is wrong, then the equation or the relation becomes. But suppose if the dimensional equation is correct, it does not mean the equation is also correct. Suppose if if the dimensional equation or the dimensional formula is wrong, then definitely the equation is wrong. But if the dimensional equation is correct, there is no need that the equation to be also correct. But if the dimensional equation is wrong, then definitely that equation or that relation is wrong. So here so next topic we have errors. How you have to calculate error. So in finding error, first you have to find absolute error. First you have to find absolute error. What is this absolute error? Absolute error actually means first you have to find the mean or average of all the values what we have in the respective or in corresponding to the physical quantity. In corresponding to the physical quantity, you should find the mean or average of all the values what we have. So here, suppose we have some values or we have some calculations like A1, A2, A3, so on. Suppose take it as A4. So we have 4 values which are respective to a physical quantity. Suppose now first we have to take the mean or average of the value. So it is A1 plus A2 plus A3 plus A4 by 4. So here we will have some value which is mean or average. So here the difference in between the mean value and each and every value will give us the absolute error. Will give us the absolute error. So suppose this value of mean or average be an. Here the difference between, suppose if you want to find the absolute error for A1, so here the delta A1 or the absolute error of A1 is equal to the difference between mean value and the actual value. So here the difference between the mean value and the actual value gives the absolute error of that particular value. So suppose if you want to find the absolute error value of A2, then delta A2 or the absolute error value of A2 is equal to the difference between mean value and the particular value A2. So the difference between the mean value and the value A2 will give us the absolute error for the value A2. So in this way, we have to find the absolute errors of each and every calculated value. Mean minus A3 will give the absolute error for A3, and then again the absolute error for A4 is mean value minus that particular value. So these delta A1, delta A2, delta A3, delta A4 are the absolute errors for the values A1, A2 and A3 and A4. Okay, so these are absolute errors. So absolute errors, so what we have done here is simply, first we have found the mean of the values what we have. So after having the value of mean, then we have to find the absolute error. This absolute error can be found like the difference between the mean value and the exact value. So, and that will give the absolute error value. So here the absolute error for the value A1 is mean minus the value A1. And then the absolute error for value A2, delta A2 is equal to the difference between mean and the value A2. So then again we can find the values of absolute errors for A3 and A4. So this is about absolute error. Then we have mean absolute error. Then we have mean absolute error. Mean absolute error values can be found by mean absolute error. Maybe from this statement only and you can understand something like that. Mean absolute error. Mean absolute error. Mean absolute error is the means of the absolute error. It is the mean or average of the absolute error. We have found in the previous case, in case of the absolute errors, we have found the absolute errors of delta A1, delta A2, delta A3 and delta A4. So here now you have to find the mean of those absolute errors, then it is mean absolute error. So it is the delta A1 plus delta A2 plus delta A3 plus delta A4 by 4 will give us the mean absolute error. Will give us the mean absolute error. So after this, we can understand that we have the value of mean AM, we have the value of mean AM, and we have this mean of absolute error. Mean of absolute error. So we have the values of AM, what we have done in the previous board, AM, which is mean, and now delta AM, which is the mean of absolute errors. So here you can write, so here the exact values can be like this. So here almost all the values will lie in the range of AM plus or minus delta AM. So these are the range of values which can exist, or these are the values which will be present. So here the minimum value should be AM minus delta AM, and the maximum value can be AM plus delta AM. So all the values will be present in between these two. All the values have to be present in between these two values of AM minus delta AM and AM plus delta AM. Next we have the third type of error called the relative error or fractional error. The relative error or fractional error. So first we shall see about the relative error and or fractional error. So here the relative error or fractional error means relative error or fractional error or fractional error. Here the relative error or fractional error is the ratio of mean absolute error and the mean value. Here the relative error or fractional error is the ratio of mean absolute error and the mean value. So here the relative error or fractional error is equal to the mean, it is the mean absolute error by the mean value. It is the ratio of mean absolute error to the mean value. Next we have, at last we have the percentage error. It is percentage error. Percentage error is the indication of this fractional error in terms of percentages. So this fractional error can be indicated. So here the fractional error is, we know that it is mean absolute error by the mean value into 100 gives the percentage. So this percentage is called percentage error. So here in this we have discussed the four types of error. The first one is absolute error, which means first you have to find the mean of the values what you have. Then you have to find the difference in between the mean and each and every value, which gives the absolute errors for each and every value. Suppose if you have the values of the A1, A2, A3 and the A4. Here suppose we have got the mean value of AM. Here the difference between the mean value AM and the A1 gives it gives the absolute error for A1. So delta A1 equal to the mean AM minus the value A1. It is the mean absolute it is the absolute error for A1. So in the same way you can find absolute errors for A1, A2, A3 and A4, and for suppose like that you can find any other values. So what we have done in the previous slide. So next after we have found mean absolute error. Mean absolute error is the average of the absolute error. It is the average of absolute error what we have found in the first case. Next we have the third case of it is the relative error or fractional error. So here the relative or fractional error, it is the ratio of mean absolute error to the mean value. Next we have the percentage error. The percentage error is indication of the fractional error in terms of percentage. So that means it is simply the delta A bar by A, which means mean absolute error by mean value into 100 gives percentage error. This percentage error. So we have next the propagation of error. Oh, so what is this propagation of error? We shall look it into now. We shall look it into it. Shall look into it. It is propagation of error. It is propagation of error. Propagation of error. Propagation of error. Propagation of error. So firstly, at the first case, we have errors in the sum of quantity. Errors as sum of quantity. Errors in sum of quantity. Suppose if we have the physical quantity x, which is the sum of two other physical quantities or two other values. So how we shall found, suppose if there is error in both the quantities A and B, so how it impacts this physical quantity x, which depends on A and B. Okay, so here if x is the physical quantity which will depend on both the physical quantities A and B, so we have written x equal to A plus B, so x is the sum of A and B. So if you have errors in the physical quantities A and B, in which manner or in which way the errors in the A and B will impact the errors or will cause the errors in x. So here the errors in the x is suppose the error in the x caused is delta x. Suppose if the error caused in A is delta A and the error caused in B is delta B. So how these errors delta A and the delta B will impact the errors in x. So here it is. Delta A plus delta B by A plus B into 100 gives the percentage error for the quantity x. If there are the absolute errors delta A and delta B for the physical quantities A and B. So here we can find this x, in which way this x can be impacted by the errors in A and B. So x equal to the error in A plus the error in B. Here the error mean, and we know that it is absolute error A plus absolute error B by A plus B into 100% percentage error in the quantity x. So error in the difference of quantity. So if the error in the difference of quantity, if there is some physical quantity like A minus B. Ready? Ready? A minus B. Then the X can be impacted in the manner such that change in the error A plus change in the error B by A minus B into 100 into 100. So this gives the error propagation if there is difference in the quantity. But if there are third type, the product of quantity, where is the third type? Product of quantity. That means product of quantity. Suppose we have A into B. Suppose we have X equal to A into B. A into B. So if there are errors, that means absolute errors in A, delta A, and absolute error in B, delta B. So in this way, these errors will result or will cause the influence on the X, or will cause the error in X delta X. So here we shall see it now. Here we can write like this as so here the maximum fractional error, the maximum fractional error. If there is product of two physical quantities, you can find it by the maximum fractional error means you know that it is the ratio of absolute, it is the ratio of mean absolute error by the mean value is equal to plus or minus as it is product. So delta A by A plus delta B by B, which gives the maximum fractional error. If the quantity, if any quantity is expressed in terms of the product of two other physical quantities. If any product is indicated in terms of the product of two other physical quantities, like this X equal to A into B, if there are absolute errors for A and B as delta A and delta B, we can find the fractional error in X as, because we know the fractional error is the ratio of mean absolute error to the average value, or the mean value is equal to plus or minus delta A by A plus delta B by B. This is the and also this is the same process what we use even if there is the division also. Even if there is the division also, if X equal to A by B also, we use the same process to find the maximum fractional error. So if it is multiplication or the division, we will use the same process. We will use the same process to find the error. So we can find again here in case of the division also, the maximum fractional error equal to the mean absolute error by mean value equal to plus or minus absolute error by the exact value plus the absolute error in B, delta B by the actual value B. So here we have seen up to now, if the quantities are, if any physical quantity is indicated in terms of the sum or the subtraction or the difference or product or division, we have seen these four types. If any quantity is indicated in terms of the sum or difference or product or division of any other two quantities, we can find errors in those quantities in this manner. But what happens if we have given or if any physical quantity is in terms of the power of the other physical quantity? Now what happens, we shall see if any physical quantity is indicated in terms of the powers of the other physical quantity. So for example, here we have the physical quantity again here x equal to a power n by b power n. So here we have the physical quantity x, which is indicated in terms of a and b, but in powers of a and b, it is x equal to an a power n by b power m. Then we can find the error in x, or the fractional error in x is again delta x by x equal to n into delta a by a plus m into delta b by b. So this gives the value of fractional error if any physical quantity is indicated in terms of powers of the other physical quantity. So here the physical quantity x is indicated in terms of the powers of the other two physical quantities a and b. So here then we can find the fractional error in the physical quantity x like this. It is plus or minus n into the mean absolute error delta a by the mean value plus m into mean absolute error of b delta b by b. Problem start చేస్తున్నాను. Problem start చేస్తాను అంటున్నాను. So here on the based on this topic we have some problems and we shall look at those problems now. So we have the problem 1 here. It is which of the following that does not depict the exact relation between technology and physics. Because we know that optical fibers, and we know that the meaning of optic means light. Optical fibers which carry the information in the form of light. So the optical fibers will carry the information in the form of light, but this would be only possible with the help of total internal reflection. So this total internal reflection, by this phenomena of total internal reflection, these optical fibers can be able to transmit information. So that is the exact relation between it is the relation between the technology and physics. So next, nuclear, it is the nuclear reactor and nuclear fusion. We know that in nuclear reactor we use nuclear. In nuclear reactor, we use nuclear fission. We use nuclear fission, not fusion. We use fission. So nuclear fission reaction is used in the nuclear reactor, so not fusion. So that is incorrect. So next option is electron microscope. It depends on the wavelength of electron. Yes, it is. Because electron microscope, we know that it is used to magnify up to some 1 million times. So to magnify up to the 1 million times, its wavelength should be also such smaller. So so here the functioning of electron microscope depends on the wavelength of electron. Next, electric generator depends on laws of electromagnetic induction. Absolutely. Because of the electromagnetic induction only the working of electric generator is possible. So here from in the option B we have seen that the nuclear reactor works on nuclear fission but not on fusion. So the incorrect option is B, because nuclear reactor works on based on nuclear fission reaction, not on fusion. So now we have the question number 2. Which of the following laws of physics is across all domains of nature? Now we have option A, the Newton's laws of motion. So first of all, we have been very fond of the Newton's laws of motion, which we have been and habituated to learn the Newton's laws of motion. But one thing we have to understand is this Newton's laws of motion can be applicable only if the particle size is more than 10 power minus 6 meters. That means 1 micrometer. So only if the particle size is more than 1 micrometer, we can apply the Newton's laws of motion. If the particle size is less than 1 micrometer, we cannot apply the Newton's laws of motion to study their motion. Next we have the conservation of momentum. The conservation of momentum will happen only in elastic collision. Only in elastic collision. But this conservation of momentum will not occur in inelastic collision. So we know that almost all collisions are inelastic collisions. So the conservation of momentum is not applicable across all domains of nature as like the Newton's laws of motion. So next option C, conservation of the energy. Of course, the conservation of energy, we have seen that the conservation of energy both in terms of micro and macro scale. Because we have the quantum theory which explains the conservation of energy at the level of electrons and atoms which are very very smaller than 1 micrometer. And also this conservation of the energy can be applicable to the larger sized objects which are more than of size 10 power minus 6 meters. So this conservation of the energy can be applied in all domains of nature. So it is option C. Next, the question number 3, it is the astronomical unit is the average distance in between the Earth and Sun. Actually, the astronomical distance is the The astronomical unit is the average distance in between Earth and Sun, which is almost 15 crores kilometers. 15 crores kilometers means we know that it can be written as 1.5 into 10 to the power of 8 kilometers, or 1.5 into 10 to the power of 11 meters. So this is one astronomical unit. One astronomical unit equal to 1.5 into 10 to the power of 8 kilometers, or 1.5 into 10 to the power of 11 meters. And we know that the speed of the light travels at almost speed of 3 into 10 to the power of 8 meter per second. So the speed of the light in astronomical units per minute is. So first we have to calculate one thing. What is the actual amount of time it takes for the light to travel from Sun to Earth? We know that the distance between, or the average distance in between the Earth and Sun is 1 astronomical unit is equal to 1.5 into 10 to the power of 8 kilometers. And we also know that speed of the light equal to 3 into 10 to the power of 8 meter per second. It is nothing but 3 into 10 to the power 5 kilometers per second. So he is asking speed of the light in astronomical units per minute. So here you have the distance, you have the speed, now you have to find time. You know that speed equal to distance by time. Distance by time. Here the distance is how much? 1.5 into 10 to the power of 8 kilometers. The time is how much? Sorry. From this, here we want to find the time. So if you want to find the time, time is equal to distance by speed. It is distance by speed. So here the distance is how much? 1.5 into 10 to the power of 8 kilometers. Speed is how much? 3 into 10 to the power of 5 kilometers. So if you get nearly as 1.5 by 3, 1 by 2 into 10 to the power of 8 into 10 to the power of minus 5. So you will get 0.5 into 10 to the power of minus 8 minus 5, which gives us 3. So 0.5 into 10 to the power of 3. So 10 to the power of 3 means we know that it is 1000. So 0.5 into 1000, it gives 500 seconds. It is 500 seconds. So if the time is 500 seconds, so here we got the time equal to 500 seconds. So he is asking per minute. So 560 means what are the number of minutes we have? We know that per 1 minute there will be 60 seconds. So 500 by 60 gives how much? It gives almost 8.3. That means he gives 8 minutes 20 seconds. 8 minutes 20 seconds. So it takes 8 minutes 20 seconds to travel from. I hope you understand why we have written this 8.33 as 8 minutes 20 seconds. Because if 1 minute is made into 3 parts, if 0.33 means you have to make that 1 minute into 3 parts. If you made it into 3 parts, 60 seconds as 3 parts, 20 seconds, 20 seconds. So if it is only the first third part, so it is 8 minutes 20 seconds. So he is asking per minute. So it is obviously 8.33 means what we have, or 8 minutes 20 seconds. So the speed in terms of the distance by time it is. Distance is to travel 1 astronomical unit, it takes 8.33 minutes. So 1 by 8.33 gives the amount of the speed of light which is traveled in 1 minute of time, which gives 0.12 astronomical units per minute. 0.12 astronomical units per minute. So it is option B according to the given data. So first we have found the astronomical unit which are given as 1.5 into 10 to the power of 8 kilometers. Then we have speed of the light which is 3 into 10 to the power of 8 meter per second. So we have to write the meter per second in terms of kilometer per second. So it is 3 into 10 to the power 5 kilometer per second. Next we have speed equal to the distance by time, as we have to find here the time first. So time equal to distance by speed. So here the distance is how much? 1 astronomical unit. It is obviously 1.5 into 10 to the power of 8 kilometers. That's by your speed 3 into 10 to the power of 5 kilometers. So if you make this, you will get 500 seconds is the time. So if you convert that 500 seconds in terms of minutes, and you are getting 8.33 minutes. So here he is asking what is the speed per 1 minute. So per 1 minute means the distance traveled by the time. So it gives the distance is 1 astronomical unit by minute. It is 8.33. It takes total 8.33 minutes. So in 1 minute it travels 0.12 astronomical units. So this is problem number 3. What I discussed. So here we have seen this problem. The wrong unit conversion among the following is. The wrong unit conversion among the following is 1 angstrom equal to 10 to the power of minus 10 meters. 1 Fermi is equal to 10 to the power of minus 15 meters. 1 light year is 9.46 into 10 to the power of 15 meters. That means here 1 light year is the distance traveled by the light of in the year of 1 year. So 1 light year is the distance traveled by the light in the time of 1 year. Here the next fourth option is 1 parsecond. 1 parsecond is 3 light years. It is 3.08 light years. So it is 3.08 into 10 to the power of 16 meters. Next at the last we have 1 AU. AU means the 1 astronomical unit. So 1 astronomical unit equal to 1 point. We have known that. We have seen that 1.5 is almost 1.5 into 10 to the power of 8 kilometers. But here given here is 1.496 into 10. So it is option E is strong option in the given. But question number 4. Next we have the question number 5. Which of the following physical quantities is not a for fundamental unit? Because as I have told you at the starting of the chapter, there are 7 for fundamental physical quantities. You see those options. Length, mass is there in the list of the 7 fundamental physical quantities. See option C, magnetic field is not there in the list of fundamental physical quantities if you observe. Next option D, electric current is there in the list of the 7 fundamental physical quantities. So it is option C, which is not a fundamental physical quantity. Here the fundamental physical quantity means it is the physical quantity which can exist on its own, not depending on any other physical quantity, and almost all the physical quantities can be represented in terms of the 7 fundamental physical quantities. Next we have the SI unit of intensity of wave. Here what you have to understand is intensity. Intensity of wave, it is the power of the light incident per area. It is the power of the light incident per area, and we know that the power is here the intensity is the power of the light incident per area. So here we know that the power is indicated in terms of watts and the area is indicated in terms of meter square, because intensity I equal to power incident on the given area. So here the power has the units of watts, which is indicated by capital W, by area is, we know that area unit is meter square. So it is watt per meter square or watt meter power minus 2. So this is the unit of intensity of a wave. So it is option 3, it is option C, which is watt meter inverse square. Next, we have problem number 7, the essence of thermal conductivity. So we know that what is meant by thermal conductivity. First, we have to write the formula to indicate the SI unit. In terms of these, as we have known that every other physical quantities can be actually represented in terms of the 7 fundamental physical quantities. So you have to represent this physical quantity of thermal conductivity in terms of the 7 fundamental physical quantities. Then we have to write U. So here we know that the amount of the heat supplied, so the amount of the heat energy or the amount of the heat flow per time is equal to K, which is thermal conductivity, into area into change in temperature by so here we have Q by T. Q by T is the rate of flow of heat. So rate of flow of heat means the heat is flowing with respect to time. So Q by T with respect to the amount of the heat energy per time, the amount of heat flow per time equal to Ka delta T by D. From this we can write here is asking about thermal conductivity. Thermal conductivity. Thermal conductivity is K. Is K. So from this you can write K equal to QD by A into T delta T. Delta T. So here what we can actually write is so here the amount of the Q by T is the amount of heat energy supplied. So the amount of the heat energy supplied or the amount of the rate of flow of the heat, it is power. Power means the amount of the heat energy supplied, Q by T into D by A into delta T. So here the amount of the heat flow, the rate of heat flow Q by T is given as watt, and we know that the distance is in terms of meters and area is meter square change in temperature. It is the temperature as indicated in terms of Kelvin. So from this we can have meter gets cancelled. So you have watt per meter into Kelvin. So it is watt into meter inverse into Kelvin inverse is the essence of thermal conductivity K. So it is option C. So from here we can see it as option C. So here we have the rate of flow of heat Q by T equal to Ka into delta T by D. So here is asking about thermal conductivity. Here the thermal conductivity is K. So from this we can write K equal to Q by T into D by A into delta T change in temperature. So Q by T means which gives the rate of flow of heat, which gives the amount of work done. So which is work done means it has a unit of watt by the distance meter, obviously area is meter square and the change in temperature is Kelvin. So here watt into meter by meter square into Kelvin, and meter will get cancelled. So watt by meter into Kelvin. So watt meter inverse Kelvin inverse, it is the unit. So it is the essence of thermal conductivity K. It is option C for problem number 7. And problem number 8, the essence of power is. The essence of power is what? You know that what we have discussed just now. The essence of power is what? And the essence of electron mobility. Now we have to find this because this is a more interesting question. As like the thermal conductivity, what is the unit of electron mobility? I think many of you may know that electron mobility. Here we have some relation for electron mobility. We know that drift velocity or average velocity equal to the electron mobility into electric field applied. So from this here you want only electron mobility. So mu equal to Vd by E. Vd means drift velocity, E means applied electric field. So here as it is Vd means what? Drift velocity or average velocity. So velocity is displacement by time. So displacement means length by time by applied velocity. We know that V equal to ED. So from that we can write E equal to V by D. E equal to V by D. So we know that the unit of length is meter. By time is second. So here if you make it like this, here again the unit of distance is meter and the applied voltage is volt by volt. So here from this you can see it is m square by so here you can write it as m square meter square into second inverse volt inverse. It is the SI unit per mobility of the electron. So it is electron mobility mu equal to Vd by E. So here Vd is the diffraction velocity. We know that the diffraction velocity is the length or the displacement by time, and the applied field E, which is electric field, is equal to voltage by the distance. So here we know that the length is has the unit of meter. So it is meter by second into here voltage unit is volt by the distance meter. So we have written like this, meter per volt. So it is meter into meter, meter square, second inverse, volt inverse. So it is option A for problem number 9. So the SI unit of electron mobility is meter square, second inverse, volt inverse. Next we have problem number 10. Which of the following quantities has not expressed in proper units? The first option is torque. Here we know that torque equal to R into F. R means the distance or the radius. Here torque, tau. You know that the torque is indicated by tau. Torque is indicated by tau. So this torque tau is equal to R into F. R means the radius, which is obviously the distance, which has to be indicated in terms of meters. So here we know that F is force, which has SI unit of Newton. So it is Newton meter. It is Newton meter. Next we have option B, it is stress. Stress equal to force acting per area. Stress equal to force acting per area. Here the stress is indicated by sigma. Sigma equal to force acting per area. Force means again it is Newton and area is meter square. So it is Newton per meter square or Newton meter power minus 2. Next you have modulus. So here the modulus is stress by strain. Stress by strain. So here we have found here the stress has the SI unit of Newton meter inverse square. Then strain is what? Strain is change in length by actual length. So here change in length and the length both has a unit of meter and meter, so the both get cancelled. So strain is a change in length by length. So if you write in somewhat detail, again stress equal to force acting by area and strain is change in length by actual length of the object. So force by area we have got here Newton per meter square, and the change in length is also a length. So it is meter per meter. So it is again Newton meter inverse square. So A, B, C are true. Next option D, power. Power equal to work done per time. We know that power equal to work done per time. So work done equal to force into displacement by time. Here we know that the unit of force is Newton, the displacement is meter, and time is second. So it is Newton meter second inverse. So option D, power, is also true. Next, E, surface tension. Surface tension is force acting per length. It is actually force acting per length. So it should be Newton per meter or Newton meter inverse. So but here in this he has given surface tension equal to Newton meter inverse square. So here option D is wrong. So answer is option E, which is incorrect. Now you have a problem. If the error in measuring the radius of the sphere is 2% and in the measuring of mass is 3%, then the error in the density of material. So here the error in the radius of sphere is 2%. So this is problem 10. I hope you understand. If you want to check it, see the slide again. Please. Next here we have a problem. So here if the error in measuring the radius of the sphere is, here the error in measuring the radius is 2%. Error in measuring the radius is 2%. That means it is given in the percentage. So here we know that the percentage error is what we have learned in the previous case is percentage error means mean absolute error by the mean value into 100. Mean absolute error by the actual value into 100 gives percentage error. So here it gives 2%. Next it is, and the error in finding the mass is 3%. Delta m by m is into 100 is 3%. So then find the error in finding the or in calculating the density of material rho. So here we know that the density equal to the density rho is equal to mass. The density rho is equal to mass by volume. Mass by volume. So here we have the given object as sphere. So the volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of the sphere as we have known it. So here the density equal to mass by volume. Here the error in the, so if you are given any quantity in terms of the division of two quantities, you can find its error by adding what we have learned in the previous topic of propagation of errors. So in the propagation of errors, we have seen if any physical quantity like this, the density is given in terms of the division of two other physical quantities, we can find it by adding these errors. So here it's we know that here of course here 4 by 3 is a constant, pi is a constant value, so there won't be any errors for constant values. Here there are errors only in case of the radius and mass. So here mass has error of 3% and the radius of error of 2%. So here m by r cube it is. So here what happens now? Mass has 3%, delta m by m has 3% plus 3 into delta r by r. So here delta m by m has given it as 3 plus 3 into, because as we have written, if any physical quantity is indicated in terms of powers, you have to write like this. So here it is r cube, so it is 3 into the error in r. So here we have the error in r as 2%. So 3 plus 6 which gives 9 is the percentage of error in calculating the density of the substance. So it is option C. So here first we have found the error. He had given the error in the radius is 2% and the mass is 3% and he is asking the value of the density rho. So we have the value of the density rho equal to mass by volume. Volume is 4 by 3 pi r cube as he have given the radius. So here mass by volume. Here as 4 by 3 and pi are constant values, there won't be any error, so there is no need to consider those values. So here the error is only caused by the values which are changing. So here only mass and the radius are changing. So here mass is, so here the error in mass is 3% and the error in the radius is 2%. So So if you take like this, as here no need to take the values of 4 by 3 and 5. So mass by volume it is R cube. So the error in the mass is 3% obviously. So if you are given in the form of the division, we have seen in the propagation of errors, you have to add those errors. And but this R cube it is given in terms of power. So it is 3 into the error of R, error in terms of R. So it is the error in mass is 3% and plus 3 into the error in the radius into 2. So 3 plus 6 is 9% is the total error. So here now we have the other problem. Here and the body accelerates from rest with a uniform acceleration for a time t. Here is asking the uncertainty in A is 8% and the uncertainty in frequency is 4%. Find the uncertainty in the speed. So if you please look at this problem, he is giving that your body accelerates from rest with a uniform acceleration. So he is starting from rest means its starting velocity or the it is u is 0. So its starting velocity u is 0, and then it starts with a uniform acceleration from rest. The uncertainty in acceleration is 8%. Uncertainty in acceleration, that means error in the acceleration is 8%. And the uncertainty in frequency is 4%. Uncertainty in frequency is 4%. Then he is asking the uncertainty in speed. Then he is asking the uncertainty in speed. And we know that acceleration equal to change in velocity by time. Change in velocity by time. But here given at the starting instant only the starting from rest, so it is u equal to 0, that becomes v by t. So here frequency is 1 by time. We know that frequency is inversely proportional to time. So frequency f is equal to 1 by time. So you can write this as the velocity into frequency. So from that he is asking the uncertainty in speed. So here the velocity equal to acceleration by frequency. So here acceleration, the uncertainty in acceleration, if it is a by s, it is in the form of the division, you have to add those as we have already known it. So here the uncertainty in the acceleration is 8%, plus the uncertainty in the frequency is 4%. So 8 plus 4 it is obviously 12% is the uncertainty in the speed or velocity of the object if it is starting from rest. If it has uncertainty in the acceleration, it is 8% and uncertainty in the frequency is 4%. As we know that acceleration equal to change in velocity by time. We are given the object is starting from rest, so you have to take the u as 0. So a equal to v by t, and we also know the frequency is inversely proportional to time. So f equal to 1 by t. So here we have v by t, acceleration equal to v by t. So here 1 by t becomes frequency, so it is vf. But he is asking the uncertainty in the speed, so v equal to a by f. So if it is given in the form of the division, here the error can be calculated like this, and you have to add those two errors. So the error in the a acceleration is 8% and the error in the frequency is 4%. 8% plus 4% gives 12% of the error in speed. Next problem, smallest division of the main scale of the vernier caliper is 0.5 millimeter, and the vernier scale has 25 divisions and these pointed with 24 main scale divisions. The least count of vernier caliper is. I think we all know about, and we have done some experiment in case of or with the help of vernier caliper. So we shall see in detail now how we shall solve this problem with the use of vernier caliper. So here given the smallest division of the main scale is 0.5 millimeter. We know that and the vernier calipers will have two scales, main scale and a vernier scale. Main scale here each smallest division on the main scale is divided into 10 parts on the vernier scale. So here the smallest length that can be calculated with the help of main scale is 0.5 millimeter. So that has to be taken into 10 parts. So here it has given that the vernier scale has 25 divisions and these points are with 24 main scale divisions. So 25 vernier scale division, 25 vernier scale divisions is equal to 24 main scale divisions. So here he is asking the least count of vernier calipers. So here what we have to do, 1 VSD, the vernier scale division equal to 24 by 25 main scale division. So here the least count equal to 1 main scale division minus 1 vernier scale division. So 1 main scale division minus 1 vernier scale division, we have 24 by 25 main scale division. So if you take main scale division as common, it is 1 minus 24 by 25. Obviously you will get MSD into 25 minus 24, 1 by 25. 1 by 25. It is the least count. But here given the smallest main scale division is 0.5 mm. So it is 1 by 25 into 0.5 mm. So it gives the value 0.002 centimeters. It gives the value 0.002 centimeters, which is option B. Inko half an hour cheddam. So here next is a problem. If the length and time period of an oscillating pendulum has errors of 1% and 3% respectively, that means here the error in the length is 1%, the error in the time period is 3%, and the error in the measurement of acceleration due to gravity. So here first we should know that the formula for So here, first you should know the formula for the time period of a simple pendulum. The time period of a simple pendulum is T, the time period T equal to 2 pi root over L by G. But now he is asking the error in the measurement of acceleration due to gravity. That means he is asking the error in the measurement of value of small g, which is acceleration due to gravity. So here you can write squaring on both sides, T square equal to 4 pi square into L by G. From this you can have the value of G as 4 pi square L by T square. So here we know that pi is constant, 4 is constant, so there is no need to consider those values. So here G is equal to L by T square in finding the error, because the errors in the length and time only can influence the error in G, because the 4 and pi are constant. So here we have taken the only values of length and time period. So here we have already known the division it is. So here the division is we have to add those errors. So here the error in the length is given as 1% and the error in time period is given as 3%. So it is 1% plus it is T square 2 into the error in time period. The error in time period is 3%. 2 into 3, which gives 7% error in calculation of G, which is option D. Is option D. Next, problem number 18. Here the measured value of length of a simple pendulum. Here the measured value of length of a simple pendulum is 20 centimeters with known 2 millimeter accuracy. The time for 40 or 50 oscillations was measured to be 40 seconds with 1 second resolution. And calculate the percentage accuracy in the determination of acceleration due to gravity. And voice సరిపోద్దా ఇంకా పెంచాలా ఇంకొంచెం పెంచాలా వాయిస్ Okay, next we have the problem number 18, which is the measured value of length of a simple pendulum is 20 centimeters. So here the length of the simple pendulum is 20 centimeters. and with a 2 millimeter accuracy. With a 2 millimeter accuracy. We know that 1 centimeter equal to 10 millimeters. So from here we can write 1 millimeter equal to 0.1 centimeter. So he has given 2 millimeter. So obviously it is 0.2 centimeter. So here the measured value is in the range of 20 plus or minus 0.2 centimeter. And also there are 50 oscillations which was measured to be in 40 seconds. So for each oscillation it takes, there are 50 oscillations happened in 40 seconds of time. That means in 1 second of time it takes 40 by 50, which is obviously 0. Sir, huh? Now comes down. So here in 1 second, for 40 seconds it takes 50 oscillations, means in 1 second it takes so here and for the 50 oscillations which happen in 40 seconds, we have 1 second resolution. So that means here the error is 1 second. It can be plus or minus. So here the time duration is 40 seconds and the resolution is 1 second. Now he is asking what the percentage accuracy in the determination of acceleration due to gravity for a simple pendulum. Again we know that T equal to 2 pi root over L by G. Now he is asking the percentage error in acceleration of gravity. So from this 2 pi root over L by G, we have written in the previous problem G equal to 4 pi square L by T square. So here, so G is equal to, as 4 pi square is constant again, so it is L by T square. L by T square. So here, the change in length or the error in the length is 0.2 and the actual length is 20 into 100, which gives percentage error in the length, plus 2 into the as it is T square, 2 into the error in the time is 1. So here we have for one oscillation, it takes almost 40 by 50, which is 0.8 seconds. So for one oscillation, it takes 0.8 seconds. So in total for 50 oscillations, it takes 40 seconds, and the error is 1 second. So here it is 2 into the changing time is 1 second, the actual time is 40 into 100. So 0.2 by 100 means obviously it is 100, 100 and 100 by 100 get cancelled, and 1 plus 2 into 1 by 40. Plus 5. It is 6%, which is option A. Which is option A. So here from again we have the time period equal to 2 pi root over L by G. From this, if you get squaring on both sides as in the previous problem, we will get G equal to 4 pi square L by T square. So again here G depends on L and the T square. So here L is the change in or the error in the L by actual length into 100 plus here it is T square, so it is 2 into the error in the time by actual time into 100. So here the error in the length is 0.2 and the actual length is 20 into 100. So 0.2 by 20 gives 1 by 100 into 100. 100 gets cancelled, so you get 1. So here 2 into, so here the error in the time is 1 and the actual time is 1 by 40 into 100. If you get cancelled, you will get 5. So 1 plus 5 is obviously 6% of the error in the measurement of value of G. Next we have problem number 19. In problem number 19, he had given the diameter of a given wire is measured by screw gauge. So here, if it is measured by screw gauge, the three measurements from the here the three measurements are given 0.036 and 0.035 and 0.037 centimeters. So he is asking the percentage error of measurement. So to find the percentage error, we have known that we have to find first the fractional error or the relative error. So here to find up a percentage error, we have to find the fractional error. So fractional error is, we know that it is mean absolute error by, mean. So first you have to find the mean of these three measurements. So we have three measurements, 0.036 and 0.035 plus 0.037. by 3. So this gives the mean absolute, so it gives the mean of those three measurements. Mean of those three measurements will give the value of 0.036. So now to find the fractional error, we should have the mean value and also mean of the errors. So mean of the errors means, here the error, we know that absolute errors are found like this. Absolute error for A1, for suppose it is AM minus the error. So AM minus the error, which is the mean is 0.036 minus the error is 0.036. Obviously here the error is 0. Next, the absolute error for A2 is the mean 0.036 minus the actual calculated value 0.035, we get it as 0.001. Next, the absolute error in A3 is the mean value 0.036 minus the given value 0.036. Here we are getting it as 0.001. So these are the absolute errors what we have found in this case. So here now you have to find the average or mean of these absolute errors, because that gives mean absolute error. We know that the mean absolute error is the mean or the average of the three absolute errors we have. So here the three absolute errors are 0, 0.001 and 0.001. So here the mean or average of the three absolute errors is 0.001 plus 0.001 by the number of the measurements 3. So here, as we have only two measurements, (0.002 by 2), you will get 0.001 as mean absolute error. So now you have to find fractional error. Fractional error is, it is the mean absolute error by mean value. It is the mean absolute error by mean value. So the mean absolute error is 0.001 by mean value 0.036. So this is the fractional error. Now you have to find its percentage. So into 100, which will give obviously 2.8 percentage. Is option B. Okay, అంటే ఒక 2 minutes అంటే ఆగుదాం, నాకు కొంచెం ఇబ్బందిగా ఉంది. ఒక్క 2 minutes ఆగుదాము అంటున్నా. ఒక 2 minutes ఆగుదాం. ఓకేనా? ఒక 2 minutes ఆగనా? అయితే అన్నిటి కొంచెం తీయండి. క్లాస్ బాగానే ఉందా? బాగానే ఉందా?